When upgrading a home's electrical service to 200 amps and changing both panels, there are several key areas to consider. These include exterior cable routing, grounding and neutral conductors, downstairs panel relocation, upstairs panel replacement, and additional considerations for safety and compliance. Firstly, let's examine exterior cable routing. It is suggested to use polyvinyl chloride, commonly known as PVC, conduit for protection of the wires as well as for aesthetics. PVC conduit provides a physical barrier against damage from weather, impact, and other environmental factors. Consider burying the conduit underground. This offers a cleaner appearance and provides additional protection from the elements. When burying conduit, ensure that it is installed at the proper depth as specified by local codes. Secondly, make sure the conduit has proper slope and drainage to prevent water accumulation. Water accumulation inside the conduit can damage the wires and create a safety hazard. Now let's move to the grounding and neutral conductors. Run both the grounding and cold water ground conductors on the exterior of the house. This ensures that the grounding system is properly connected to the earth, providing a path for fault currents. Use copper rods or pipes for grounding and a ground clamp to connect to the water pipe. Copper is an excellent conductor and provides a reliable connection to the earth. Ensure the conductors are properly sized and routed according to local codes. The size of the grounding conductor is determined by the size of the service entrance conductors as specified in the National Electrical Code, commonly known as NEC Table 250.122. Next, the downstairs panel relocation. Ensure there is sufficient space beside the meters for the new outdoor panel. The new panel should be easily accessible for maintenance and repairs. Provide a weatherproof panel enclosure to protect the panel from the elements. A National Electrical Manufacturers Association, commonly known as NEMA, 3R enclosure is typically used for outdoor applications. Run new service cables directly from the meter base to the outdoor panel. The service cable should be sized according to the new 200 amp service requirements. Now let's discuss the upstairs panel replacement. Replace the existing panel with a 100 amp fuse panel. Fuses provide overcurrent protection for the circuits in the panel. Use new service cables to connect the panel to the meter base. The service cable should be sized according to the electrical load of the upstairs. Ensure the panel is properly sized for the electrical load of the upstairs. This includes calculating the total amperage of all the circuits in the panel and ensuring that it does not exceed the panel's rating. In addition to these specific steps, there are some additional considerations to keep in mind. Firstly, obtain permits from the local authority before starting the work. Permits ensure that the work is done in compliance with local codes and regulations. Secondly, hire a licensed electrician to perform the installation to ensure compliance with safety regulations. Licensed electricians have the knowledge and experience to safely and correctly install the new electrical service. Thirdly, consider installing a surge protector on the main electrical pole to protect sensitive appliances from power surges. Surge protectors can help to prevent damage to electronic equipment from voltage spikes. Finally, use high-quality materials and equipment to ensure a reliable and safe electrical system. Using quality components can help to prevent problems down the road. When running the cable on the exterior of the house, several methods can be employed, each with its own advantages and considerations. Firstly, direct attachment to the building surface using straps or cable ties specifically designed for outdoor use. These fasteners should be corrosion resistant and UV resistant to withstand the elements. Ensure that the cable is securely fastened to prevent sagging or movement, which can cause damage over time. The spacing between supports should comply with the NEC Article 334.30, which typically requires supports every 4½ feet and within 12 inches of boxes, cabinets, or fittings. Secondly, consider running the cable through conduit. Conduit provides physical protection for the cable and can enhance the aesthetic appeal of the installation. Options include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and PVC conduit. The choice depends on the specific requirements of the installation and local codes. Metal conduit provides superior protection against physical damage, while PVC conduit is lightweight and corrosion resistant. Thirdly, messenger wire support involves suspending the cable from a strong tensioned wire using cable clamps or ties. This method is suitable for long spans where direct attachment to the building is impractical. The messenger wire should be properly sized to support the weight of the cable and should be grounded to prevent electrical hazards. Regarding grounding and bonding, several important steps must be taken to ensure a safe and effective grounding system. Firstly, install a grounding electrode system consisting of ground rods, ground plates, or a connection to a metal water pipe. The grounding electrode system provides a low impedance path to ground for fault currents. The NEC section 250.52 specifies the requirements for grounding electrodes. Secondly, bond the metal enclosures of the service equipment, meter base, and panels to the grounding electrode system. Bonding ensures that all metal parts are at the same electrical potential, reducing the risk of electric shock. The NEC section 250.92 specifies the requirements for bonding service equipment. Thirdly, use a main bonding jumper to connect the neutral conductor to the equipment grounding conductor at the service entrance. This connection provides a path for neutral current to return to the source. The NEC section 250.28 specifies the requirements for main bonding jumpers. When relocating the downstairs panel outdoors, specific considerations must be addressed to ensure safety and compliance with electrical codes. Firstly, weatherproof enclosure. Use an M3R or 4X enclosure to protect the panel from rain, snow, and other environmental factors. The enclosure should be made of corrosion-resistant materials such as stainless steel or fiberglass. Secondly, mounting height. Mount the panel at a height that is easily accessible for maintenance and inspection. The NEC section 110.26 specifies the requirements for working space around electrical equipment. Thirdly, overcurrent protection. Install overcurrent protection devices, such as circuit breakers or fuses, in the panel to protect the circuits from overload and short circuits. The overcurrent protection devices should be properly sized for the load served by each circuit. When replacing the upstairs panel, several factors must be considered to ensure a safe and reliable installation. Firstly, load calculation. Perform a load calculation to determine the total electrical load of the upstairs circuits. This calculation should include both existing loads and any anticipated future loads. Secondly, panel size. Select a panel with sufficient capacity to accommodate the calculated load. It is generally a good idea to choose a panel with extra spaces for future expansion. Thirdly, circuit identification. Clearly label each circuit breaker or fuse in the panel to indicate the load it serves. This will make it easier to identify and troubleshoot circuits in the future. Some additional safety measures for upgrading electrical service is also good to know. Firstly, arc fault circuit interrupters, commonly known as size. Install a size on branch circuits serving bedrooms, living rooms, and other areas where arc faults are likely to occur. A size can detect arc faults and quickly de-energize the circuit, reducing the risk of fire. Secondly, ground fault circuit interrupters, commonly known as GFCIs. Install GFCIs on branch circuits serving bathrooms, kitchens, and other areas where water is present. GFCIs can detect ground faults and quickly de-energize the circuit, reducing the risk of electric shock. Thirdly, surge protection. Install a surge protector at the main service panel to protect the entire electrical system from voltage surges. Surge protectors can help to prevent damage to sensitive electronic equipment from lightning strikes and other transient voltage events. Lastly, professional inspection. Have the completed installation inspected by a qualified electrical inspector to ensure compliance with local codes and regulations. The inspector can identify any potential safety hazards and ensure that the work is done correctly. When dealing with service cables, it's important to understand their types and appropriate usage. Firstly, underground service entrance cable, commonly known as USE, is designed for direct burial in the earth and is suitable for underground service laterals. It has a moisture-resistant insulation and a tough outer jacket to protect against abrasion and corrosion. Secondly, service entrance cable, commonly known as SE, is used for above-ground service entrances and is available in two types: Type SEU, which is unarmored, and Type SER, which is armored. Type SEU is typically used for residential applications, while Type SER is used for commercial and industrial applications. Thirdly, aluminum or copper conductors. Service cables are available with either aluminum or copper conductors. Copper conductors have a higher conductivity than aluminum conductors, but aluminum conductors are lighter and less expensive. The choice of conductor material depends on the specific requirements of the installation and local codes. The NEC provides guidance on the ampacity of conductors based on their size and insulation type, as found in tables 310.15b16 through 310.15b19. When routing cables on the exterior of the house, several installation techniques can be employed to ensure neat and professional appearance. Firstly, use cable cleats or straps to secure the cable to the building surface. The cleats or straps should be spaced according to the manufacturer's recommendations and should be made of corrosion-resistant materials. Secondly, avoid sharp bends in the cable, as this can damage the insulation and reduce the cable's ampacity. Use sweeping bends to maintain the cable's integrity. Thirdly, protect the cable from physical damage by installing it in conduit or using a protective covering. This is especially important in areas where the cable is exposed to traffic or other potential hazards. Grounding and bonding are critical for electrical safety and must be performed in accordance with the NEC. Firstly, grounding electrode conductor. The grounding electrode conductor connects the grounding electrode system to the service equipment. It should be sized according to the size of the service entrance conductors, as specified in NEC Table 250.66. Secondly, equipment grounding conductor. The equipment grounding conductor provides a path for fault current to return to the source. It should be sized according to the size of the overcurrent protection device, as specified in NEC Table 250.122. Thirdly, bonding jumpers. Bonding jumpers are used to connect metal enclosures and other non-current carrying metal parts to the grounding system. They should be sized according to the size of the equipment grounding conductor. When installing a new outdoor panel, proper planning and preparation are essential. Firstly, location. Choose a location that is easily accessible for maintenance and inspection and is protected from physical damage. The location should also comply with local zoning regulations. Secondly, mounting. Mount the panel securely to wall or other structure using appropriate hardware. The panel should be level and plumb to ensure proper operation of the circuit breakers or fuses. Thirdly, wiring. Connect the service entrance conductors and branch circuit conductors to the panel according to the manufacturer's instructions and the NEC. The wiring should be neat and organized, and all connections should be tight and secure. When replacing an existing panel, it's important to take steps to minimize disruption and ensure a smooth transition. Firstly, schedule the replacement during a time when the power can be shut off for an extended period. This will minimize inconvenience to the occupants of the building. Secondly, preparation. Prepare the new panel and all necessary materials before shutting off the power. This will help to speed up the replacement process. Thirdly, labeling. Carefully label all of the existing circuits before disconnecting them from the old panel. This will make it easier to reconnect them to the new panel in the correct locations. When upgrading electrical service, consider the impact on other electrical systems in the building. Firstly, lighting. Ensure that the existing lighting system is compatible with the new service voltage. If necessary, replace lighting fixtures or ballast to accommodate the new voltage. Secondly, appliances. Check the voltage and amperage requirements of all major appliances to ensure that they are compatible with the new service. If necessary, replace appliances or install step-up or step-down transformers. Thirdly, communication systems. Protect communication systems, such as telephone and data lines, from voltage surges by installing surge protectors. Surge protectors can help to prevent damage to sensitive electronic equipment from lightning strikes and other transient voltage events. In conclusion, upgrading a home's electrical service requires careful planning, attention to detail, and compliance with all applicable codes and regulations. By following these guidelines, you can ensure a safe, reliable, and efficient electrical system for your home.